This is the key to your test review, and as I said in class, I did not do a good job of giving you any room to work at all, because to do these first few, you need to factor, and on the test, you do have room. I gave you room for that. I just didn't space all this out right before I copied it. All right, so the numerator, to factor that, it's going to look like a little equals here, I guess. It's going to give me x minus 3 times x plus 2 over x plus 2. Now, the first thing you do domain before you reduce. So your domain here, x cannot equal negative 2. So it's a set of all x's such that x cannot equal negative 2. Okay. So then I can reduce these so that my reduced function here is f of x equals x minus 3. So I have a whole. That's what happens when I reduce. The x value is negative 2. The y value, I substituted negative 2 here, will be negative 5. At this point then, I have no vertical asymptotes, so that would be none. On the second one, I can't factor it. So my domain is just going to be the set of all x's such that x cannot equal negative 5. Can't simplify anything out, so there are no wholes. And then my vertical asymptote is going to be x equals negative 5. Factor the numerator here. It's going to give me x plus 4 times x minus 4 over x times x minus 4. So then I find my domain, set of all x's such that x cannot equal negative 4 or 0. These reduce out, so my reduced function is x plus 4 over x. So I have a whole with the x value being at 4. Once I substitute 4 in here, 4 plus 4 is 8, divided by 4 would be 2. And then I have a vertical asymptote at x equals 0. All right, to factor this one, I'm going to get 3 times x minus 2 over x times x plus 8. So my domain here, a set of all x's such that x cannot equal negative 8 or 0. Then there's nothing that cancels, so there are no wholes. And my vertical asymptotes would be x equals 0 and x equals negative 8. Make sure you are writing these separately. You do not get to, when you're writing the equation of a line, you do not get to do plus or minus. You do not get to do x equals 0, comma, negative 8. Just two separate lines. X equals 0 is a line, and x equals negative 8 is a line. All right, so next part says, for each of the following rational functions, find the end behavior. So I'm just looking for the horizontal and oblique asymptotes here. I do not have to factor this. I mean, you can, but you totally don't need to. We are just looking at degrees. So this is tied in degree, which means I have a horizontal asymptote at the ratio of the leading coefficients, which would be 3/4. And so this will be none here. Then here, this is 1 degree higher in the numerator, so I'm going to need to divide. I do not get to use synthetic division here because that's an x squared in the denominator, which means I'm doing long division. This is going to give me x cubed plus 2x squared minus, or plus 0x. It doesn't really matter because it's 0, then minus 5. So x goes into x cubed, x times, so this is x cubed plus 2x, and then change my signs, so this is going to give me 2x squared minus 2x minus 5. So x squared goes into 2x squared, positive 2 times, and then I'm really done because the rest just gives me a remainder that I don't care about. So this is y equals x plus 2, which means this is none. Then here to factor this, this is going to give me, oh, I don't need to factor. What am I doing? See, I was trying to do too much there. Don't need to factor that. I'm just looking for the asymptotes. So it is bottom heavy, which means this is y equals 0, and this is none. Here we are tied in degrees, so it's the ratio of the leading coefficients. So that is going to be y equals 4. and this would be none. Then here, this is 1 degree higher in the numerator, so I need to divide, but on this one I can use synthetic division. So I'm going to have -5 on the outside. On the inside I'll have 4, -1, and 2. Let's bring the 4 down, get -20, it's -21, and then again the rest doesn't matter because this is what's giving me my equation. Y equals 4x minus 21. So this has to be none. Alright, last part on the first page. I'm looking for the x and y intercepts, but really zeros. I didn't change it over here. And so to do this, I am going to need to factor these. So on this first one here, when I factor the numerator, this is going to give me x minus 5 times x plus 1 over x minus 2 times x minus 5. All right, so that's my factored form. When I cancel these out, because I have a whole, it is gone. So I find the zeros after I reduce. So using my reduced function, which is just x plus 1 over x minus 2, my zeros are just -1. Oh, I can't even do my parentheses right. And then my y-intercept, when I substitute 0 in for x, it's going to be 0, -1/2. Okay. When I factor this one, this is going to give me x minus 3 times x plus 2 over x plus 3. So in this case, I cannot cancel anything out. And that means my zeros are going to be -2 and 3. My y-intercept is probably easier found from this right here. So I'll have 0, -2. All right, so then this last one, I would need two numbers to multiply to give me 4, but combined to give me a -1. And since my only options here are 1 and 4 or 2 and 2, this isn't going to happen, which means I can't factor it. So if I can't factor it, doesn't mean I just don't have an answer. It means I need to use the quadratic formula and see what I get there. So x equals -b, which would be a +1, plus or minus the square root of b squared, so that's -1 squared, minus 4 times a, which is 1, times c, which is -4, all over 2 times a, which is 1. So this gives me 1 plus or minus the square root. -1 squared is 1. This is going to give me a +16. So 1 plus 16 is 17 over 2. And I can't simplify that at all. 17 is a prime number, and so that is it. So my zeros are 1 plus or minus the square root of 17 over 2. My y-intercept would just be 0, 4/3. Okay. All right, page 2. So we're going to figure out all this data and graph. So my domain here is going to be the set of all x's such that x cannot equal 1. Then I need to factor this, see what's going on here. This is going to factor into x plus 5 times x minus 2 over x minus 1, which means I do not have any wholes. My roots are going to be at -5 and 2. Vertical asymptotes, x equals 1. There is no tangency or togetherness. This is top heavy, which means there is no horizontal asymptote, which means there is a slant asymptote, and I need to find it. And it is, I can use synthetic division here. So I have 1 on the outside. On the inside, I'm going to have 1, 3, -10. Okay. 1, 1, 4. So this is just going to be y equals x plus 4. My y-intercept I can get from right there, so it's going to be 0, 10. Then I need to do my number line. I put on my number line these two things. So I have -5 I have a 1, and I have a 2. So I have to test the first one for sure. And so when I substitute in like a -6 up here, this will give me negative, 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 so it's negative overall. There is no tangency or togetherness, which means I alternate. So this is negative, positive, negative, positive. All right, so then I'm going to graph everything I can over here. I have zeros at -5 and at 2. A vertical asymptote at x equals 1. And I have a horizontal asymptote, I'm sorry, a slant asymptote at y equals x plus 4. So 1, 2, 3, 4. I can just go diagonally through my squares. Like so. All right, so then I got to decide, I need my y-intercept. My y-intercept is at 0, 10. That has to be graphed as well. I need to decide if I need any more points. So I look at my sign chart here. From negative infinity to -5, my graph is negative. So from negative infinity to -5, my graph is negative, which means it's coming up along the asymptote like this. From -5 to 1, it's positive. So it says positive all the way up through there. Then from 1 to 2, it's negative, so it's coming up like this. That makes sense. And then from 2 to infinity, it's positive. So I feel like I have points, enough points here that I can just go ahead and draw this in, and I don't have to find any more. It looks something like that. And then something like this. And there you go. All right, the second one. I need to factor it so I can figure out the domain. So the numerator is going to factor into x plus 1 times x minus, back that up. That would be x plus 4 times x minus 1 over, and it's going to give me x plus 2 x plus 4. All right, so my domain is a set of all x's such that x cannot equal -4 or -2. Then I simplify, right? Those cancel out, which means I have a hole with an x value of -4. My reduced function is f of x equals x minus 1 over x plus 2. So then I substitute in the -4 right here, so it's going to be -4 minus 1 over -4 plus 2. So that's -5 over -2, which is a positive 5 halves. Okay, my roots are going to be, because remember I'm using this one now, I only use this for domain. Roots are going to be positive 1, vertical asymptote x equals -2, no tangency or togetherness. They are tied in degrees, so y equals 1. This would be none. Y-intercept would be 0, -1/2. So again, these are the two things that go on my number line. So I'm going to have -2 and 1. So I'll try -3. Substitute -3 into here. It's going to give me negative over negative, which is positive. There's no tangency or togetherness. So they alternate, positive here, negative here, positive here. So let me graph everything I can. I have a hole at -4, 1, 2, 3, 4, and 5 halves, which is 2.5. On the homework that I graded, there were quite a few people that told me you had a hole, but didn't actually go and graph it. So make sure it gets graphed. That root is at 1. Vertical asymptote is at -2. Tangency and togetherness, we don't have any. Horizontal asymptote, y equals 1. And y-intercept, 0, -1/2. So from -infinity to -2, my graph is positive. So it's positive this whole time up here, but I don't know whether or not it crosses this asymptote. We'll get back to that. And then from -2 to 1, it's negative, so it's negative right here to 1. That makes sense. And then from 1 to infinity, it's positive, so it could stay under here or it could cross that. So we need to check that. My reduced function, which is x minus 1 over x plus 2, set that equal to the expression part of the asymptote, which would be 1. Then I solve it. This gives me x minus 1 equals x plus 2. Well, when I subtract x from both sides, I get -1 equals 2, which is a false statement, which means I am not going to cross the asymptote. So I don't need any extra points here. It's fine just to come in here and don't actually go through that because it's supposed to be discontinuity there. And then it comes up like this, and we do not cross that asymptote. Okay, and there you go. Make sure that I can actually see your points. All right, next one. Going to start by factoring, so get 4 times x plus 1 over x plus 2 times x minus 2. So my domain is a set of all x's such that x cannot equal plus or minus 2. I cannot cancel anything out, therefore I do not have any discontinuity. Roots, -1. Vertical asymptotes are at x equals -2 and x equals 2. Look very carefully here. Here I put plus or minus 2, totally acceptable. Even if it was here, totally acceptable. When I am writing equations of lines, not okay. I have no tangency or togetherness. It is bottom heavy, so y equals 0, which means I do not have a slant asymptote. And then my y-intercept is going to be 0, -1. This is what I put on my number line. So I have -2, -1, and 2. If I substitute in -3 right here, this is going to give me negative, 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 which means it's negative overall. No tangency or togetherness, so they alternate. This is negative, positive, negative, positive. And I'll go over here and graph everything I can graph. So I have a root at -1, vertical asymptote at x equals -2, and x equals 2. No tangency or togetherness, horizontal asymptote, y equals 0, y-intercept 0, -1. All right, so I have from -infinity to -2, it's negative. And then from -2 to -1, it's positive, so it's positive up here. And then from -1 to 2, it's negative, which means that this is going to have the cubic in behavior, not the quadratic behavior. The first part of it's going to be down here. I know for sure it's not crossing this asymptote because it has to be negative the whole time. And then the third part's going to be up here. But I need points in these two places here. So I need to go and find that. When you do that, you have to have an actual little T-chart here where I can see where these points are coming from. You don't just have random points that pop up on your graph. So I'll try -3 and see what happens here. So when I substitute in -3, that's going to give me 4 times -2 over -1 times -5. So it's going to give me -8/5. -8/5, which is 1 3/5, which is something that we could graph here. So -3, -1 3/5, somewhere right about there. Then I need to get something on the other side over here. All right, so I'll try a +3. And then when I substitute that in, that's going to give me 4 times 4 over 5 times 1. So that gives me 16/5. So that's 3 1/5. So when I go to positive 3, I can go to 1, 2, 3 1/5. And I feel like those two are probably good enough to graph that. So this stays negative the entire time, like so. Make that point a little bit bigger there. These 2 points are really enough because I know it's positive to here, then it becomes a negative, and you have to have a point of inflection. It's not a line thing happening here. Ooh. Let me try that again. Like so. And then this stays positive the whole time, so it's going to come down and look something like that. And those are those points that I had. There you go. Don't forget your arrows on the end. I will take off points for that. All right, next one. So I factor what I can factor. Can't factor the numerator, obviously, so this is just x squared over, I can factor this. This becomes x plus 1 times x minus 1. So my domain is the set of all x's such that x cannot equal plus or minus 1. All right, I cannot reduce anything, so I have no holes. It would be none. Roots are 0. Vertical asymptote, x equals -1, x equals 1. I do have tangency or togetherness. I have tangency, because remember this comes from the numerator, this comes from the denominator. So I have tangency, and that is at x equals 0. That means I'm going to bounce, right? I am tied in degrees, so this is y equals 1. This will be none. And then my y-intercept here is going to be 0, 0. These two things on my number line, got -1, 0, and 1. So if I substitute in -2 up here, well, the numerator is going to be positive no matter what, because I'm squaring it. So when I substitute a -2 in the denominator, it'll be negative and negative, which means this is positive. I do have tangency here, so I want to be careful. So I'm going to go ahead and check the rest. If I put in -1/2, numerator is still positive. But then this is going to give me positive, negative. So that is negative. If I plug in 1/2, I get positive, negative again. So this is negative. Substitute in 2, get positive, positive. So this is positive. So positive, negative here, positive. Okay, because this is where your bounce is, where your tangency is. Let's graph everything we can. I have a 0 at 0, vertical asymptote at -1, and again at 1. I have tangency at 0, so I'm going to bounce there. I have a horizontal asymptote at y equals 1. My y-intercept 0, 0, I already have that. Okay, so let's look at what is happening here. Need some other points. So from -infinity to -1, -infinity to -1, I am positive the whole time. So this is positive the whole time. So it could be here. I could cross the asymptote. Not sure, but we'll get back to that. From -1 to 1, I'm negative the whole time. So this is going to come up and get drawn in here, and I don't have to worry about asymptote or anything else like that. This has to have that quadratic look to it. Ooh. The end behavior is quadratic anyway. And then from 1 to infinity, I am positive, but again, could cross that asymptote. We don't know, so we need to check that. So I'm going to set this x squared over x squared minus 1 equal to the 1 that is the asymptote. So I'm going to get x squared equals x squared minus 1. Well, when I subtract x squared from both sides, I get 0 equals -1, which is not a true statement, which means I am not crossing that asymptote. But I do need to find some other points. So again, make sure I have a little t-chart that I can see where your points are coming from. If I substitute in a -2, it's going to give me -2 squared over -1 times a -3. So this is going to give me 4 over 3, which is 4/3. Okay, so I can go to -2. Then 4/3 is 1 1/3. It's about right there. I feel like that's good enough to go ahead and draw that part in like this. And this I already took care of, no big deal. Then I'm going to substitute in a 2, see what happens. So it's going to give me 2 squared over 3 times 1, which is going to give me 4/3 again. So this is going to have a symmetric look to it. They don't always. So I can go to 2 and then 1 1/3. It's about right there. And my graph looks something like this. Remember, it's curvy. Make sure you're at least making an attempt not to make it look like a corner there. Right, and there's that one. All right, so the last rational here. I'm going to factor the denominator. This is going to give me 4 over, and this is going to be x minus 2 squared. It's going to be x minus 2 times x minus 2, but that is a perfect square trinomial. So my domain is a set of all x's such that x cannot equal 2. And then I have nothing I can reduce, so there are no holes. The roots, it's an empty set. I do not put none. It is empty set. Vertical asymptotes, x equals 2. I do have one of these two. I have togetherness because I have the multiplicity in the denominator. So I have togetherness at x equals 2. Horizontal asymptote would be y equals 0 because it is bottom heavy, which means I do not have a slant asymptote. And then my y-intercept is going to be 0, 1. Put these two things on here. Well, there are no roots to put on there, so I just put a 2. So when I substitute in 0 over here, that's just going to give me, well, the numerator is positive no matter what, and then the denominator is positive no matter what because I squared. So this is always going to be positive, and this is always going to be positive. So I'm not going to have anything that's negative at all. So now we're going to graph everything we can graph. I don't have any roots. I have a vertical asymptote at x equals 2. I have togetherness at x equals 2. We'll come back to that. Y equals 0 is my horizontal asymptote. And my y-intercept is 0, 1. All right, so from my sign chart, it's positive the whole time, which means I know I'm not crossing the horizontal asymptote, because if I did, it would have to be negative. So I also have togetherness at x equals 2, which means this is going to come up like this, and this side should look like this. I have 1 point over here, which I think is enough. And then I can get one on the other side that I need. So, a little T-chart. I can use 3, but there's a chance this is symmetric, so I'm going to just use 4. 3 is likely to be up here somewhere. So I use 4. It doesn't matter either way, but remember, if you get one that's up real high, you need to choose another one. Let's see what happens with 4. Substitute in 4, and you get 4 over 2 squared, so that would be 1. So we can go to 4, 1, and it is a symmetric kind of graph. So it's going to look like this and this. And there you go. So then our last one is exponential. We have to name the parent function, list the transformations, graph the function, identify its key characteristics. So the parent function here would be f of x is equal to 2 to the x power. Our transformations, that 3 right there is going to be a vertical stretch by a factor of 3. The negative right here is going to be a reflection, in the y-axis. And then all I have left is that 2 and the 6, so that's going to be a translation. I'm going to translate left 2 and down 6. All right, so when I come over here to graph this, the first thing I'm going to think about is my asymptote, which is usually at y equals 0, but if I have a vertical translation, that's going to affect that. So if it goes from 0 to negative 6, 1, 2, 3, 4, 6. So this is my horizontal asymptote here, which is now at y equals negative 6. My parent function starts at 0, 1, no matter what. I get a vertical stretch by a factor of 3, so I end up here. I reflect on the y-axis. Well, I'm on the y-axis, so I don't go anywhere. Translate to the left 2 and down 6. 3, 4, 5, 6. For my parent function, when x is 1, y is 2, I have a vertical stretch by a factor of 3, which will give me to 6 here. I reflect on the y-axis, go to the left 2 and down 6. And I'm right there. Then when I'm at negative 1, y is 1/2. So I have a vertical stretch by a factor of 3, which would be 3/2, which takes me right there. I reflect on the y-axis, translate to the left 2, and down 1, 2, 3, 4, 5, 6. Okay, so now the only point that I'm missing on here is my y-intercept, so I need to find that out, which means I need to find f of 0. It's going to be equal to 3 times 2 to the 0. If x is 0, then that's going to give me the negative 2 power minus 6. Okay, so that means that I have 3 times, well, 2 squared is 4, the negative makes it 1/4, and minus 6. So they give me 3/4 minus 24/4, which will give me negative 21/4. So my y-intercept is at 0, negative 21/4. Negative 21/4. So that'll be negative 5 1/4. So 1, 2, 3, 4. 1, 2, 3, 4, 5 1/4 is right about there for my y-intercept. Then my graph. Oh, shoot. Okay, get the right angle here. Something like that. Here we go. Okay, so my domain here, negative infinity to infinity. My range, negative 6 to infinity. I do not include the negative 6. It is not increasing anywhere. It is decreasing over the entire thing. My end behavior, as x approaches infinity, f of x approaches negative 6, and as x approaches negative infinity, f of x approaches infinity. Okay, and there you go. That is the only exponential type stuff that will be on your test, just the graphing, not any of the solving or application problems. That'll be on your next test.